Lesson 2. Blockchain. Blockchain is the fundamental technology for cryptocurrencies. Without it, digital assets in the modern sense of the word can't be created. So, in this lesson, we'll discover what blockchain is, what a consensus algorithm is, the difference between proof of work and proof of stake. Let's begin. Blockchain. What is it? Blockchain is an essential technology on which the whole crypto industry is built. Every cryptocurrency has a blockchain at its core, and this is how cryptocurrencies differ from a more global concept, digital or virtual currency. But what is blockchain? Technically, it refers to distributed ledger technology, allowing data to be recorded and shared across a network. It involves several independent computers called nodes. This is a key difference between the distributed ledger and the traditional one, where all information is stored centrally. DLT is commonly used to refer to a distributed ledger technology. Blockchain is the first efficiently working and fully implemented example of DLT. However, these concepts are not synonymous. Blockchain is one type of DLT and serves only as a subcategory of a broader concept. The scientific definition of blockchain technology is a replicated distributed database. The term database is quite clear. For instance, it's the address book on your smartphone. A distributed database implies that the address book is used not only by you, but also by a certain group of people. Plus, it's stored on your phone and the phones of all those people using it. The word replicated is the most difficult term in the definition. It comes from the word replica, which in IT refers to a copy of an information object, such as a database, that is automatically updated when the original changes. In other words, a replicated database implies that all copies of the address book are exactly the same on all devices. This is because any changes that are made on any database are immediately copied to the others. This means that if one user adds a contact on their device, all the other users will get this contact. Obviously, blockchain isn't an address book. It's literally a chain of blocks. Each block contains a certain amount of information, and together they form a database. What can a database of any cryptocurrency store? Well, it can include data on how many crypto units have been created and all the information about their movement, which addresses each unit was transferred to, the complete transaction chain, its timing, and other details. For example, Bitcoin's blockchain is over 420 gigabits as of late August 2022. As you've already realized, each copy of the blockchain holds all this information and is absolutely identical to the rest of the copies. Hopefully, now the scientific definition of blockchain doesn't seem so complicated and confusing to you. Blockchain features and consensus algorithms. Blockchain has several features. The first and main feature is immutability. You can't change the order of the records in each block and the order of the blocks themselves in the blockchain. If information is added to the blockchain, it remains unchanged. That's why crypto transactions are irreversible. Once the transaction is made, the block adds information about transferring a certain amount of cryptocurrency from one address to another. This information is added to all copies of the blockchain in the network. There is no way to change it. Fun fact, the prototype of blockchain technology was described by Scott Stornetta and Stuart Haber in 1991, and it emerged as a technical solution designed to eliminate the possibility of backdating digital documents or correcting their date after the event. The second feature is decentralization. It's worth mentioning again, copies of the blockchain, each of which is a complete database or ledger, are stored on several independent computers known as nodes. Nodes act both as the data repository and as the database operator. Only nodes can make changes to the blockchain. For example, they record transactions within the network. Other network participants ask the node to add their transactions to the blockchain. A consensus mechanism is used to make such a system work. Consensus involves all network participants agreeing on the current state of data in the blockchain without requiring them to trust each other. Consensus mechanisms enable the blockchain to be truly decentralized, eliminating the need for an administrator or other center to verify that this copy is correct. Today, there are two main consensus mechanisms: proof of work and proof of stake. The first algorithm, proof of work, is Satoshi Nakamoto's brainchild, the very mechanism behind Bitcoin. Its practical execution is called mining. The process boils down to a miner adding a transaction to a block and a block to a chain to calculate a random set of letters and numbers created by processing the data through a hash function. This set of characters is called a hash. The miner calculates two hashes. A root hash, aka the hash tree or a Merkle tree, is the first one. The algorithm calculates hashes of transactions placed in a block. Hashes from the sum of transaction hashes, then hashes from the sum of hashes from the sum of hashes, and so on until a single hash is obtained. The Merkle root. It's a cryptographic proof of block integrity, and its value is fixed in the block header. It sounds complicated, but calculating the Merkle root is a very small part of the mining process and doesn't require much processing power. A block hash is the second one. It supplements the Merkle root data in the block header with other information: block version number, the hash of the previous block header, current timestamp expressed in seconds, etc. Calculating the block hash seems to be a simple task, but its execution is entirely random. The only way to find that hash is to try every possible combination while processing a huge amount of data. That's why mining difficulty is measured in hashes per second. The first one to find a suitable block hash is the luckiest. The randomness factor ensures the security of the system because the attacker can't add a fake block. It's quite easy to check if the hash is calculated correctly. The verification is carried out by other miners. Once the calculation is validated the required number of times, the consensus is reached. This is where the proof of work takes place. Once consensus is reached, the miner asks the node to add its block to the chain. This way, mining is a process of calculating blocks, offering a reward from the system for the work done. Proof of work gave birth to a whole generation of different consensus algorithms, but they all have two key drawbacks: excessive energy consumption and low bandwidth, resulting in scaling problems for projects based on them. In 2011, as an alternative, proof of stake was proposed at the Bitcoin Talk forum. The concept assumes that those nodes which have locked a certain amount of funds can process transactions and add new blocks to the chain. This is known as staking. Instead of proof of work, users determine the correct block by digitally signed voting. So, the block receiving the maximum number of votes is added to the chain. If the node behavior turns out to be malicious, its locked funds are burned. This is how things work in a very simplified way. Besides, the proof-of-stake algorithm has different versions, and many extensions have also been created based on it. There are also other alternative consensus algorithms. Some are a mixture of proof of work and proof of stake. Others develop their own ideas. But in the end, they all strive to make the network reliable, ergonomic, fast, and secure. Apart from consensus algorithms, blockchain networks also differ in type. Vitalik Buterin, Ethereum co-founder, formulated the most common typology. It is also called the Canadian typology and includes three types of blockchain. 1. Public blockchain. 2. Consortium blockchain. 3. Fully private blockchain. There is another British typology which was formulated by Mark Walport, Government Chief Scientific Advisor, in his report Distributed Ledger Technology, Beyond Blockchain. 1. Permissionless blockchain. 2. Public permission blockchain. 3. Private permission blockchain. Here's another way to classify blockchains. 1. Unpermitted public ledgers. 2. Permissioned public ledgers. 3. Permissioned private ledgers. Basically, all these classifications are similar. 1. Permissionless blockchain and unpermitted public ledgers are analogous to a public blockchain. 2. Public permissioned blockchain and permissioned public ledgers are analogous to a consortium blockchain. 3. Private permissioned blockchain and permissioned private ledgers are similar to a fully private blockchain. Mark Walport created a short visual test to help people understand the differences between various blockchain types. This test makes it easy to identify the type of blockchain with minimal knowledge of the topic. These blockchains essentially differ only in their structure, which implies various levels of access to information. At the same time, the division is conditional because the principle of blockchain technology remains the same. For instance, there are state blockchains, which are the basis for central bank digital currencies. They have a structure of either permissioned public ledgers or permissioned private ledgers. In the first case, the user can exploit the blockchain without an intermediary. In the second case, they only use it through a certain interface with no access to the database. In both scenarios, the state delegates the functions of the node to selected financial entities. And yet, blockchain retains the principle of immutability and, in part, decentralization. Transparency is the third important feature of blockchain technology. Like decentralization, it's fully realized only in public blockchains. But at the same time, hiding something in the blockchain or fixing it retroactively still remains impossible. So, even a fully private state blockchain can't hide anything if it gets audited. Moreover, deleting such a database is problematic because it's distributed. This feature makes blockchain a truly revolutionary technology that has already gone far beyond the cryptocurrency market. Blockchain is actively used in logistics processes, production and transportation quality control, environmental projects, document management, public administration, and many other areas. Summary. In this 10-minute video lesson, we've learned what blockchain is, different blockchain classifications, consensus algorithms, their types, and features. What features of blockchain technologies make it the most useful in the crypto industry. In the third lesson, we'll discuss what digital assets are and how they differ from each other. See you in our next video.